Okay, good morning, everyone. Get your coffee situated and let's dive in. How many of you checked your horoscope this morning? Be honest, no judgment here. Okay, so keep that in your back pocket. We're going to come back to horoscopes at the end of class, and I'm going to show you a test that you can run that's going to teach you something about correlation and association and what we're talking about today. So today we're tackling one of the most important concepts you'll learn, not just in this class, but in your entire psychology education, maybe even in your entire college career. And here's the thing, once you understand what I'm about to teach you, you're going to see the world differently. You'll never watch the news the same way. You'll never scroll through social media the same way. You'll become that annoying friend at parties who says, correlation doesn't imply causation. And yes, you will become that person, trust me. So we're talking about association, about correlation, what it means, how to properly identify it, and most importantly, how to avoid being fooled by it. Because here's the reality. Every single day, people, researchers, journalists, your Uncle Bob on Facebook, advertisers, even therapists, they're all making claims about relationships between things, and they're doing it wrong most of the time. All right, so let's start with the basics. What do we mean by association? An association is simply a relationship between two variables. When one thing changes, the other thing tends to change in some predictable way. That's it. Okay, pretty simple, right? Now, association comes in three flavors. First is positive association. When one variable goes up, the other tends to go up too. The classic example is hours studied and exam scores. Generally speaking, and I said generally, so don't come crying to me if you study for 47 hours and still bomb the test. The more you study, the better you do, generally. That's a positive association. Second is negative association. When one variable goes up, the other goes up. For an example, hours spent partying the night before an exam and exam scores. The more you party, the worse you do. That's a negative association. Shocking, I know. Third is no association. Sometimes there's just nothing, no relationship at all, like the color of your socks and your exam performance. Purple socks don't make you smarter. Sorry to disappoint you if you were counting on that. So now here's where it gets interesting, where people start screwing up. How do you actually establish that association exists? So let me tell you what most people do. They notice some examples like, hey, I wore my lucky socks and I got an A, and I wore them again and got another A. There's definitely a relationship here. And that's essentially how humans have been thinking for thousands of years. We see a pattern and we assume it's real. The problem is our brains are pattern detection machines, and our brains see patterns even when they don't exist. So how do scientists actually determine if an association is real? Let me introduce you to the 2x2 table. So let's use a real example from psychology, one that's actually quite controversial, multiple personality disorder. It's now called dissociative identity disorder, or MPD/DID. There's a theory that multiple personality disorder is caused by childhood trauma, particularly sex or physical abuse. Now, to test whether childhood trauma and MPD are actually associated, we need information about all four of these cells. So cell 1 would be people who reported childhood trauma and have MPD. Cell 2 is people who reported childhood trauma but don't have MPD. Cell 3 is people who did not report trauma but do have MPD. And cell 4 is people who have neither. So here's the critical part, so listen carefully. You need all four cells, not one, not two, not three, all four. Without all four, you literally cannot determine if an association exists. And yet, most people, including some professionals, draw conclusions based on just one cell, usually on cell 1. So let me show you how this works mathematically. Okay, we calculate two rates. Rate 1 is cell 1 divided by cell 1 plus cell 2. Now, this is just an average, okay? So we're taking an average of the top two cells of what's the average of people who report childhood trauma versus the average of people who report no trauma, okay? So rate 1 is the rate of multiple personality disorder amongst people who reported trauma. Rate 2, you take cell 3 and divide it by cell 3 plus cell 4. This is the rate of multiple personality disorder among people who did not report trauma. And then we compare them. If rate 1 is greater than rate 2, we have a positive association. If rate 1 is less than rate 2, we have a negative association. And if they equal each other, there's no association at all. So let me give you a concrete example. Suppose a clinician has 20 patients, 5 patients reported trauma and were diagnosed, 5 reported trauma and weren't diagnosed, 5 reported no trauma but were diagnosed, and 5 reported no trauma and were not diagnosed. So what are our rates? Rate 1 is 5 divided by 5 plus 5, which, equals 0.5, and rate 2 is the same. Okay, they're equal, which means there's no association between reported childhood trauma and multiple personality disorder in this made-up sample, even though 5 people had both trauma and MPD. So I'm going to give you an assignment with the real research so that you can calculate this for yourself and see what the real research says, well, we won't talk so much about what the author says, but there's research on both sides of it. So I just found some of the more recent research articles about it, and that's what some of your homework is going to be. Okay. So now that you understand the proper way to establish association, let's talk about the 2 most common ways that people screw this up, and I mean constantly screw this up in published research, in the media, in clinical practice, everywhere. So mistake number 1 is presuming association through mere examples. This is the yes mistake. People focus exclusively on cell 1, cases where both things are present, and ignore everything else. So here's how it happens. A therapist works with patients who have multiple personalities. She notices that many of them report childhood trauma, and she thinks, aha, MPD and trauma are linked. She might even see like the 5 patients who have both trauma and multiple personality disorder, but what she's not noticing or documenting is the patients with trauma who don't have MPD, or the patients with MPD who don't have trauma, or the patients with neither. So she's literally working with only a quarter of the information she needs, and based on that quarter, she's drawing a conclusion. And this is actually what happened with the whole recovered memory movement in the 80s and 90s. Therapists saw patients with MPD, many reported trauma, and they concluded trauma causes MPD. And the problem is they never systematically collected data on all 4 cells. Okay? Think about it this way. If I show you 10 people who smoke and have lung cancer, does that prove smoking causes cancer? No, because I haven't told you how many smokers don't have cancer, how many non-smokers do have cancer, and how many non-smokers don't have cancer. Okay, you need the full picture. Mistake number 2 is presuming association through a lone rate. This is slightly more sophisticated, but it's still wrong. So here's how it works. A researcher studies people with multiple personality disorder and finds that 70% of them report childhood trauma. Wow, the researcher says 70% is really high. Clearly, trauma is associated with MPD, which sounds reasonable, right? But the problem is, what's the rate of trauma in people without MPD? Okay, we don't know based on this. And that's the whole problem. Maybe 70% of the general population reports childhood trauma. And if that's true, then a 70% rate in multiple personality patients is completely meaningless. There's no association at all. Or maybe 80% of people without multiple personality disorder report childhood trauma. And if that's true, then we actually have a negative association. People with trauma are less likely to have MPD. Okay? And this actually happens in real research. The book mentions that life history interviews with almost any psychological disorder reveals high rates of reported childhood trauma because trauma is unfortunately extremely common. Okay. One study even found that a carefully screened sample of 100 adults with no mental disorders still had common childhood trauma. Okay. So if trauma is common everywhere, it can't explain why a specific person develops a specific disorder. So to show that trauma is associated with MPD specifically, you have to show that the rate of MPD is higher amongst people with trauma than amongst people without trauma. Okay. Okay, now let's get to the big one, the phrase you've probably heard before, maybe even hopefully in other classes. Correlation does not imply causation. Okay, tattoo it on your brain, make it your phone wallpaper. This is one of the most important principles in all of science. So far, we've been talking about association or correlation, just establishing that 2 things are related, but we really want to know in psychology and in life is what causes what. Okay, we want to know, does childhood trauma cause MPD? Does depression cause academic problems? Or do academic problems cause depression? Do playing violent video games, does that cause aggression? Does smoking marijuana cause psychosis? These are causal questions. All those things are correlated, but are they causal? And here's the thing, you cannot answer a causal question with correlational data alone. Okay, let me say that again because students miss this every single semester. You cannot answer a causal question with correlational data alone. Okay? When you find a correlation between X and Y, there are three possible causal relationships. Option one is X causes Y. Maybe childhood trauma really does cause multiple personalities, and that's the hypothesis we're testing. Option two is Y causes X, which is weird. How can multiple personality disorder cause trauma? Well, it can't cause actual trauma, okay? But here's what could happen. A diagnosis of multiple personalities might cause therapists to search for trauma memories. They might encourage patients to recover memories of abuse. The diagnosis comes first in this case, and then the trauma reports follow. So the direction of causation is reversed. And this actually happened, by the way. Remember from chapter 1, that story? It's not hypothetical. You know, after the book and movie about Sybil came out, watch it or read it if you haven't yet, there was an explosion of multiple personality disorders diagnoses, and therapists started to search for trauma in these patients' histories, okay? Option 3 is Z causes both X and Y. So this is called the third variable problem, and it's the most insidious one. Maybe some other factor, what we call spurious correlation, Z, okay, causes both trauma and multiple personality disorder diagnosis. So what could Z be? Well, the research suggests several possibilities for multiple personalities. Suggestibility, people who are highly suggestible might be more likely to both develop dissociative symptoms and create false memories of trauma. Fantasy proneness, similar idea. Hypnotizability, people who score high on hypnotizability skills are more susceptible to developing both multiple personality disorder symptoms and false memories. Okay, see how tricky this is? You observe a correlation between trauma and multiple personalities, but the real cause might be something else entirely that's causing both of them. Okay. 3 conditions for causality. So how do you establish causation? You need 3 things, okay, 3 conditions. So condition 1 is X and Y obviously have to be correlated. If they're not even associated, X can't be causing Y. That's an easy one. Condition 2 is X must precede Y in time. This is called the directionality problem or temporal precedent. Temporal means time, from Latin tempus, meaning time. The cause has to come before the effect. Again, seems obvious, right? But in the trauma MPD case, this is actually problematic. Multiple personality disorders usually diagnosed in adults, but the trauma is supposed to have happened in childhood. How do we know? Well, we ask the adult about their childhood. But if the diagnosis comes first and then the patient recovers trauma memories, we have a directionality problem. Condition 3 is all other factors must be ruled out. This is the third variable problem, again, and it's usually the killer. To prove that X causes Y, you have to rule out all other explanations. All of them, every single one. Can you really do that? Can you ever be 100% certain that you've ruled out every possible third variable? Not really. And that's why establishing causation is so difficult and why we have to be so careful about causal claims. So let me give you an example of how to build a causal argument when you can't do a randomized experiment, because obviously we can't randomly assign people to smoke cigarettes for 30 years just to see what happens. The example is smoking and lung cancer. So this is now accepted as a causal relationship, but how did scientists establish that without being able to do controlled experiments on humans? So a researcher named Hill proposed 5 criteria for building causal arguments from correlational data. So he said 1, consistency. Do results replicate across many studies? For smoking and cancer, yes. Dozens of large studies from different countries, different time periods, different research teams all show the same relationship. 2 is strength of association. Is the association clinically meaningful or is it trivial? For smoking, it's very strong. There's actually a dose-response relationship. The more you smoke, the greater your risk. That's powerful evidence. Okay. Speaking of which, dose-response relationship, do higher levels of the cause produce stronger effects? For this, the longer you smoke, the greater the risk. The more cigarettes per day, the greater the risk. If you quit, it decreases the risk. Filtered tipped cigarettes somewhat lower the risk than unfiltered. So see how all of these are pointing to the same conclusion? 4 is plausibility. So is there a scientifically reasonable mechanism for smoking? Yes. We know cigarette smoke contains carcinogens. We know those carcinogens are inhaled directly into the lungs. We know they damage DNA. The mechanism makes sense. 5 is coherence. This is the big one. Is the explanation collectively stronger than any single alternative? Can any other explanation account for all the evidence? With smoking, the coherent argument goes like this. Tobacco smoke contains toxic substances that damage lung tissue when inhaled. This explains why smokers get lung cancer more than non-smokers. why heavier smoking increases risks, why quitting reduces risk, why pipe and cigar smokers who don't inhale have lower risks, why filter cigarettes are slightly safer, and so on. Okay. Could there be a third variable? Sure. Maybe people who choose to smoke have some genetic factor that causes both smoking behavior and lung cancer. But would that genetic factor explain the dose-response relationship? The decrease in risk after quitting, the difference between inhaled and non-inhaled smoke? Unlikely. By far, the simplest explanation is that smoking causes cancer. And this is where Occam's razor comes in. Occam's razor is when multiple explanations fit the data, we prefer the simplest one. The simplest one is usually right. So this is how you build a causal argument from correlational data, not with one study, not with one correlation, but with a pattern of evidence that all points to the same conclusion, and that can't be explained by alternative hypotheses. Okay? All right, now I'm going to tell you why you should trust basically nothing you read in the news about health and psychology. The media is terrible at understanding association and causation. And I don't just mean they get it wrong occasionally. I mean they get it wrong constantly, systematically, predictably. Why? Because the media isn't in the business of informing you. They're in the business of getting your attention. And what gets attention is individual stories that are vivid, dramatic, emotional, stories about specific people. Causal claims, X causes Y, is more interesting than X is correlated with Y. And simple narratives, complicated statistical arguments don't go viral. Okay. So let me give you some examples from the book. Example 1 is orchestra conductors. So you might have heard that orchestra conductors live longer than average. The media loves this story. The secret to long life, conduct an orchestra. So here are the numbers they cite. Orchestra conductors lived an average of 73.4 years compared to 68.5 years for the general U.S. male population. This was done back in 1978. So 5-year difference, right? That's huge. So music must be really good for you, right? What they don't tell you is the general U.S. male population includes everyone. Infants who died at birth, children who died in accidents, teenagers who died in cars. But the orchestra conductors, obviously none of them died as infants or they wouldn't have become orchestra conductors, okay? So when they did a more appropriate comparison, comparing male orchestra conductors to other males who survived to age 32, the difference totally disappeared, okay? So the orchestra conductors live longer claim is based on a completely bogus comparison, but it made a great headline. Okay, and we also see the same thing like with, people in ancient days, they only lived until 35. Well, yeah, because that's including all the babies that died and all the teenagers that died. But if you get past the teenage years, back then they would live just as long as we live now, roughly speaking. So there's lots of old people back then, just like there's lots of old people now. It's just that our babies are more likely to survive today. Our teenagers are more likely to survive. Example number 2 is vegetarian diet. So here's another one you've probably seen. Vegetarians are healthier, they live longer, they have better cardiovascular health. The evidence is studies showing that vegetarians have these lower rates, that they do live longer, which sounds convincing, right? Must be the lack of meat. But wait, how do people become vegetarians? Do researchers, randomly assign people at birth? You're going to be vegetarian and you're going to eat meat. Obviously not, right? So people choose to become vegetarians. And who chooses to become a vegetarian? People who are health conscious, people who exercise regularly, they don't smoke, they don't drink, they care about their bodies, they tend not to overeat, they're avoiding sedentary lifestyles. So obviously, hopefully, you can see the problem. Vegetarians differ from meat eaters in 1,000 ways that have nothing to do with whether they eat meat. And any of those other factors could explain the health difference. So this is the third variable problem in action, and it's everywhere in health research. To actually test whether vegetarians are healthier, you'd need to randomly assign people to vegetarian or meat-eating diets to eliminate self-selection and make everything else equal. Same exercise, same alcohol consumption, same total calories. You'd have to use blind evaluators who don't know which group the participants are in. You'd have to monitor compliance to make sure they're following the diet, measure health outcomes for a sufficient amount of time. And has this been done? For long-term health outcomes? No, not really. It would be incredibly expensive and difficult. So when you see headlines about vegetarian diets, remember you're looking at correlational data from self-selected groups. That's not proof of causation. Okay, so let me summarize the media's favorite tricks. Favorite ways to mislead you. They cherry pick examples, sell one only. They report single rates with no comparison. They make bogus comparisons. between non-equivalent groups. They use causal language for correlational findings. They say causes instead of is associated with. They feature dramatic individual stories instead of statistical data. Okay, so what is your defense? Every time you see a claim about health psychology, behavior, in the media, ask yourself, is this based on all 4 cells or just examples, just cell 1? Are they comparing appropriate groups? Could this be explained by a third variable? And are they claiming causation or are they claiming correlation? Okay, are they claiming causation when they should be claiming correlation? So if correlational data is problematic, what's the alternative? The alternative is experiments. So a proper randomized controlled experiment solves all 3 problems. With correlation, you can observe whether X and Y are actually related in an experiment. Directionality problem, you manipulate X and then you measure Y so you know X came first. The third variables, random assignment means all other factors are, at least theoretically, equally distributed across groups. It at least decreases the chance of a third variable issue. So random assignment is, of course, the key. If you randomly assign people to conditions, then on average, every other variable, personality, intelligence, genetic, upbringing, they should be equal across groups. The only thing that differs is what you manipulated. And this is why experiments are the gold standard in science. But, and this is important, experiments aren't always possible for ethical reasons. You can't randomly assign people to smoke or experience trauma or develop mental illness. Practical reasons, you can't control people's entire lives for, 30 years. The nature of the question, you can't manipulate some variables, like whether someone was abused as a child. When experiments aren't possible, you need to build causal arguments using Hill's criteria. Multiple correlations form a coherent pattern with alternative explanations ruled out through, logic and additional data and so on. But whenever possible, do the experiment. All right, so let me come back to where we started, horoscopes. So remember I asked, who checks their horoscope? Well, here's a test you could do tonight with your friends. The book suggests this, and I've also tried it in class many times. It's never worked. So here's what you do. Get a group of people together, the more the merrier. Get yesterday's horoscopes from any newspaper or offline. Read them in random order without saying which sign is which, and then ask each person to identify which horoscope is theirs, based on how well it matched yesterday's events. If horoscopes actually worked, if there's a real correlation between your sign and your day-to-day life, then people should be able to identify their horoscope at a much better than chance rate. We'd expect at least 75% accuracy if there was real predictive power, but if they don't work, then the success rate should be about 1 in 12, roughly 8%, basically random guessing. So I've run this test in class multiple times. No one has ever achieved better than chance performance. The success rate is always around 8 to 10%, okay? But the book says, that after the test, even when people fail miserably, they still insist that horoscopes usually work. Why? Because they're relying on examples. They remember the hits, they forget the misses, that confirmation bias. So this is the danger of reasoning from examples instead of systematic data. Our memories are selective. We notice and remember things that confirm what we already believe. Okay, so what did we learn today? Key points. 1, to establish association, you need all 4 cells of the 2x2 table. 2, mere examples are insufficient. You need systematic comparison of rates. 3, correlation does not imply causation. 4, 3 conditions are necessary for causality: correlation, temporal precedence, the time issue, and ruling out third variables. And when experiments aren't possible, you have to build causal arguments using Hill's criteria, those 5 criteria for causality. 6 is the media systematically misrepresents correlational evidence. And 7 is your best defense against the media is to ask for experimental data, or at a minimum, a coherent pattern of correlations. Okay, I need proof. So the mantra is correlation does not imply causation. Okay, so good. Don't forget it. So I will see you in the next class. Remember to be skeptical, think critically, and please, for the love of science, stop letting the media manipulate you with bad statistics. See you in the next class.